Hey students, today's lesson is on approximating square roots. So we'll start with some vocabulary. An irrational number is a number that cannot be written as the ratio of two integers. In other words, it can't be written as a fraction. And then real numbers is the set of all rational and irrational numbers. So here we have this little Venn diagram that's not overlapping at all because a number can't be both rational and irrational. It's one or the other. But the two combined form the set of all real numbers. Now notice that within rational numbers, we have a lot of other categories. Some rational numbers are also integers, positive or negative whole numbers. Some integers could also be whole numbers, so that includes 0 and all positive integers. And then we have natural numbers, which is only positive integers, so not including 0 or any negative integers. So let's classify some numbers that we see. Let's start with the square root of 12. Now, we know that the square root of 12, that 12 itself is not a perfect square, so the square root of 12 will not be an integer. I'm going to write here under reasoning, not perfect square. And that means this is not a rational number at all. If we have the square root of a number that's not a perfect square, we're going to have a decimal that does not repeat and does not terminate, which makes it an irrational number. Now the second number we have is a decimal, and it does not terminate. We see it has the bar over the top to show that that point, that 25, those two digits are going to repeat over and over again, negative 0.252525. But because it's repeating, that does make it rational. We can write this as a fraction, as a ratio of two integers, and we'll learn how to do that soon. It is not itself an integer, which means it also can't be a whole number or a natural number. Okay, and we'll put as our reasoning it repeats. Now we have negative square root of 9. So that would be negative 3. Negative 3 is certainly a rational number, and it's an integer. But because it's negative, it's not a whole number, and it's not a natural number. Then we have 72 over 4, which simplifies to 18. That's a rational number. That's also an integer. And because it's positive, it's also both a whole number and a natural number. The only number that's whole but not natural would be 0. And then last we have pi. That is like our standard irrational number. It's non-terminating, non-repeating. Okay, so that is classification of numbers. Now we're going to get into approximating square roots. So we want to take the square root of 71 and without a calculator, estimate to the nearest integer, and then we'll also estimate to the nearest tenth. So for part A, we're going to estimate to the nearest integer. So we want to think of some perfect squares that we know that are close to 71. So 64 would be an example of a perfect square that's close to 71. Its square root would be 8. So if the number is 8, its square would be 64. And then 9 is our next integer, and 9 squared is 81. So we could do 10 also, but really we only need these two because 71 falls between 64 and 81. So now we just have to think, if we want to the nearest integer, what is it closer to? 71 is a little bit closer to 64 than it is to 81. So we'll say the square root of 71 is about equal to 8 to the nearest integer. Now we want to estimate a little bit closer. So we know it's between 8 and 9. The square root of 71 is between 8 and 9, closer to 8 than to 9, but it was pretty close to in the middle. So let's start with 8.3. And this is where you have to use a little bit of long division. I'm not going to do it here, but you multiply 8.3 times 8.3, and you're going to get 68.3 8, 9. So we're a little low. So let's try our next tenth. That's 8.4. Multiply 8.4 times 8.4, and it's 70.56. So we're very close to 71. But let's go ahead and try one more to make sure that it's not closer. So 8.5 times 8.5 is 72.25. So now we're a little too high. So we know that our square root of 71 falls between 8.4 and 8.5, but closer to 8.4. So the square root of 71 is about equal to 8.4. And that's how we're going to estimate those. Okay, last example. We're going to compare which is greater, square root of 5 or 2 2/3. So let's start by drawing a number line. And as we think about how we want to number this, we know that 2 2/3 falls between 2 and 3. And square root of 5, let's see, square root of 4 is 2, and square root of 9 is 3. So square root of 5 should fall between 2 and 3 as well. So let's go ahead and just do 2 1/3, 2 2/3, and we'll kind of estimate these. So 2 2/3 obviously falls right here, 2 2/3. And then square root of 5, we can kind of think to ourselves, we know that it's somewhere over here near 2. Let's try 2.2 squared, and we can multiply that, and we find 4.84. So 2.2 is a little bit small. 2.3 squared is 5.29. So 2.3 is a little bit too big for the square root of 5. So if we're looking at our number line, we're saying it's somewhere between 2.2 and 2.3, somewhere right about there. Square root of 5, and this is 2 2/3. So which one is bigger? Definitely the 2 2/3, and we can use estimation to find that. All right, so go ahead and try a few on your own. I'll see you soon.